Hey there, I'm Roberta. I'm one of the founding faculty members here at Auro EDU, and I'll be your go-to person for all things science in class ninth. Now, I'm not your average teacher. I'm more like a mentor, a guide, and maybe even a friend. My job is to show you how science isn't just something you learn in a textbook. It's a tool for shaping the future, your future. Welcome to Mind, Matter, and the Cosmos, Scientific Possibilities. This isn't your typical science class. We're going way beyond the usual. We're going to explore things like ethical hacking, cybersecurity, AI, and biotech. But we'll also dive into mind-blowing topics like quantum sensors for brain imaging, exoplanets, and the cutting-edge world of quantum computing. We'll even talk about how neuroscience is unlocking the secrets of the human brain and how biohacking is opening doors to personal enhancements you never imagined. By the time we're done, you'll not only understand these cool topics, you'll see them in action and maybe even find your future career in one of these fields. Whether it's engineering, math, or space sciences, the possibilities are endless. So get ready for a journey that's not just about learning facts, it's about discovering how you can make an impact. Let's get started. Today we're going to explore something amazing: quantum sensors for brain imaging. This is part of our course, Mind, Matter, and the Cosmos, Scientific Possibilities. In this session, we'll uncover how scientists use futuristic technology to understand our brain without touching it, just by listening to its tiny magnetic whispers. Let's begin. This session connects big ideas, like how our mind and the universe are linked through science. You'll learn how new tools, like quantum sensors, help us look inside the brain. Why does this matter? Because it helps doctors find brain problems early and helps scientists understand how we think. By the end, you'll know how brain tech works and how it's changing the world. What are quantum sensors? Quantum sensors are super sensitive tools. They can detect signals so tiny that normal machines can't even notice them. They use the weird but powerful rules of quantum physics, like how atoms and light behave. These tools help us see brain activity without touching it. They're used in hospitals, labs, and even space science. Types of quantum sensors. Not all quantum sensors are the same. Some measure magnetic fields, called magnetometers. Others track gravity, gravimeters. And some keep time with perfect precision, atomic clocks. For brain research, magnetometers are most useful. They help scientists find out what parts of your brain are working and when. Each sensor has its own special job. Quantum versus regular sensors. Quantum sensors are way more sensitive than regular ones. Think of it like using a telescope versus your naked eye. They also don't need big machines to work, and they give clearer images of the brain. This means faster, safer, and smarter ways to learn what's happening in our heads. Magnetic fields in the brain. Our brain sends signals using electricity, tiny zaps between cells called neurons. Every time this happens, it also creates a magnetic field. These fields are natural and safe, and scientists can read them using quantum sensors. That's how they listen to our brain. Why it's hard to detect brain magnetism. The brain's magnetic signals are incredibly weak, like a whisper in a loud room. And the earth, electronics, and even lights around us create noise that makes it hard to hear them. That's why scientists need special tools, like quantum sensors, to filter out the noise and catch these faint signals. What are OPMs? One of the coolest tools for brain imaging is called OPM, Optically Pumped Magnetometers. They're small, safe, and use light to detect brain magnetism. They can be worn like a helmet, making brain scans more comfortable. No more lying still inside a huge machine. How OPMs work. OPMs use lasers to wake up atoms inside them. These atoms start reacting when they sense brain magnetism. Then, the sensor watches those changes and turns them into brain maps. It's like using invisible waves to create a photo of your thoughts. OPMs in a lab. In a lab, OPMs are placed on your scalp using soft headgear. You can sit or move a little while the machine watches your brain. It shows your brain activity live on a screen, like a movie of your mind. Labs keep the room quiet to reduce outside noise. Brain mapping basics. Brain mapping turns brain signals into colorful maps. Red areas might show lots of activity, blue areas less. These maps help doctors and scientists see what each brain part does. It's also used to spot learning or memory problems. Using quantum sensors for mapping. With quantum sensors, we can track brain activity in real time. We can see what's happening when you talk, move, or think. It's safe and doesn't hurt at all. Just a smart helmet, some sensors, and a screen full of brain action. Real-world applications. These brain maps help people in many ways. Someone who can't speak can use their brain signals to type. Doctors can learn about mental health and how we learn. Quantum brain tech is already changing lives every day. Diagnosing brain diseases. Quantum sensors can help find diseases early, like Alzheimer's or epilepsy. The scans are painless and don't need injections. This helps doctors plan better treatments, and patients don't need to go through scary tests. Case studies. Doctors have used these sensors to find the source of seizures in epilepsy patients. They've also helped detect Alzheimer's before symptoms start. Teachers even use them to understand how students learn best. Real science, helping real people. The future of brain research. Quantum sensors will keep getting better, smaller, faster, and more powerful. They'll help us understand memory, emotions, and even how the brain heals. And they'll be used all over the world, even in small clinics and schools. Quantum tech in everyday life. Soon, you might have quantum sensors in your phone or smartwatch. They could track sleep, focus, or stress. Quantum clocks already make GPS more accurate. And yes, this means more cool jobs in tech too. Skills for the quantum future. To get into this world, start with curiosity. Learn some basic math and coding. Practice teamwork and sharing ideas. Science is not just facts. It's about asking good questions. These skills can lead you into exciting careers later. Careers in brain research. You could become a brain scanner expert, a quantum engineer, or a science teacher. These jobs help people and use fun tech every day. Your interest in science today could turn into a big discovery tomorrow. Keep learning. We've explored how quantum sensors are changing brain science. From seeing how we think to treating diseases early, this tech is powerful and exciting. It's safe, smart, and full of possibilities. And you? You could be part of it. Stay curious, keep asking questions, and one day, you might lead the next big breakthrough.